Okay, this is from your final study guide for your college algebra final exam. I'm on number 23. We've got stuff from section 1.8. This is absolute value. The first step in an absolute value is to isolate the absolute value sign. So I'm going to move the 6 across. So subtract 6, and still an absolute value, but we've simplified it. So you want to simplify first. Absolute isolated equal to a constant. If this is a positive number, there's two possibilities. What's inside of this absolute value sign could be positive 4 and equal 4, or negative 4's absolute value is 4. So there's two equations, 5x plus 3, what makes that equal 4, and what makes 5x plus 3 equal negative 4. That's our two questions. Then solving each one of these equations, we get one solution that x could be 1/5 in work, and then the other one, 5x equals negative 7. When we divide by 5, it's negative 7/5. So the solution set, two solutions, 1/5, negative 7/5. Okay, number 24 is a similar situation, only now we have an inequality symbol in it. It's an absolute value plus 6 less than 8. So just like the last one, we do need to isolate it first, so move the 6 over. That's still an absolute value signs, but then when we minus 6, that will be a 2. So isolate first, very important. Then there's two possibilities. Anything that would make this quantity less than 2 would be a solution. Also, anything that makes 8x plus 3 greater than negative 2 would be a solution. So when you do this, you write it like it is the first time. That's assuming this is a positive number, and there's two solutions then. You write it as it is without the absolutes. Then you write it again, that 8x plus 3 written again. You flip the sign and that sign. You have to change the inequality sign direction and the sign of the number. That work gives us our two equations to solve, giving us a solution of x is less than negative 1/8. And then do it again here for the other solution if x is greater than negative 5x. Now, since this is an inequality, the solution needs to be written in interval notation. So think about what this looks like on the number line. You got negative 5/8 to the left of negative 1/8, you know, the smaller number. Here, the smaller number is a negative 5/8 than negative 1/8. So this says that it's things that are less than negative 1/8, so go in this direction, but also greater than negative 5/8, so this direction. So it winds up being that section in the middle. You could also use the strategy of taking a test point and seeing what works in the original inequality. That's the idea of a solution, what works in the problem. So you should be able to take anything out of that little section, plug it into the original problem, it should work. And then anything that's not in the solution shouldn't work. So you could verify it by testing a few points. But when you read this, that is what it says. Less than negative 1/8, greater than negative 5/8, which would be the middle section. Now, because there is no line under it, no equal sign, that means we're not including the endpoints, so it's parentheses. So the interval is things from negative 5/8 to negative 1/8. It's a small interval. Okay, that's answer C. Number 25, a similar problem, continuing the theme of absolute value. And as you see, this is the third one now. We need to isolate this before we proceed. So very important, remember if there's any constants or multipliers, anything around this absolute value sign, you have to isolate it first. It's still an absolute value signs, but we have removed the negative 8 across and simplified it. Simplify it first. You should always simplify things as much as you can as a first step. Then, just like the last problem, if this be a positive number, there's two possibilities. Whatever makes 8x minus 8 greater than or equal to 8, write it like it is. Then write it again, 8x minus 8, flip the inequality and change its sign of the constant. Working through this, you'll see it does give you the correct solution set. So you're solving like you do any equation. Only thing is, if you would divide or multiply by a negative, we do know it flips the inequality sign, but that hasn't come up in these examples. So solving through this one, -8 and 8 is 0, but that's okay. Keep rolling along. 0 is a number. Malfunctioning there. And it tells me that the two solutions, it's greater than or equal to 2 and less than or equal to 0. Let's see how that looks on the number line. 0 would be to the left of 2, so get those in the right order. And then greater than or equal to 2, because it has the equal to line under it, means use a bracket, include the endpoint. Less than or equal to 0 goes this direction. So it splits apart. And guys, that is true on all of these. If it's a greater than, it winds up being a split apart. You'll have to union the two regions. If it's a less than, original problem's a less than, it winds up being in the middle. But once again, you can always take a test point and see that this is so. If this truly is the solution, anything in this region should solve it. Anything in this region should solve it. In this region, if we tested like the point 1 or 1.5, anything out of that region shouldn't work. If this be the true solution set. So anything from -infinity to 0, union, 2 to positive infinity should work when plugged into that equation. All right, so that concludes the Chapter 1 material on this study guide. Chapter 2 starts with number 26. Number 26 is a problem that involves finding the center and the radius of a circle. And that would be from section 2.1. Now, what makes me think this might be a circle? Well, also the directions say find the center and radius of this circle. But even without the directions, I would suspect this to be a circle formula because it has an x squared and a y squared with equal coefficients. They're both plus and equal coefficients, so it's set up like something I would expect to be a circle, possibly a circle. So you collect your x squared and your x's, and your y squared and your y's, you know, kind of ordering these, getting it in an order, and any constant I'll throw to the other side. So what I want to do is complete the square of each one of these to get it in center radius formula form. So to complete the square, you have to have a 1 coefficient on your square term. If it's not a 1, you need to divide through by any other constant, any other a term there. So if this is a 1, the completing the square process is half, you half the middle term, the x term or the y term, and square that value. That is the number that completes this square that will let us get it in the right form. So half of 8 is 4, 4 squared is 16. If I add 16 to the left, I have to add 16 to the right. The reason for that is that guarantees this to factor into a binomial squared. This would be considered a perfect square trinomial when you add in that special number. This always factors into a binomial squared. The square root of the front number, the square root of that back number, and then the sign of its middle term. You could check it out. X plus 4 times x plus 4 does FOIL to give you that. Anyway, so that works. Do the same thing to your y's. Do the half the middle and squared. So half of 10 is 5. 5 squared is 25. If I add 25 to the left, I have to add 25 to the right. That makes this now factorable just like before. There's a plus sign between these. And then you've got your y. Your 25 square root is 5, and it's a minus this time. 8 plus 16 plus 25, let's see, I think that is 49. And now this is in the circle center radius format. The center radius formula looks like this: x minus h squared, y minus k squared equals the radius squared. So we know that the h and the k value are centering. Because there's a negative in the formula, it changes the sign of these numbers. This would be x minus a -4 would be its h value. So we change the sign of these for its centering. It will be a -4 and a +5. That's the center of this circle. And this is the radius in its squared format, so we have to square root it to know that the radius is the square root of 49 or 7. And then we could sketch a graph if requested. Okay, the next problem, number 27, is also of this type. We're going to use the center radius format on it as well, but we're going to kind of work it backwards. It gives us 2 points. It says these 2 points would be endpoints of a diameter of a circle. So if you went through, the diameter would go through the center, and the center would be the midpoint of this segment. So if we know we've got a point -5, 1 and a point at 3, 7, we'll find our center by the midpoint formula, which says add the x's, half them, add the y's, and half. In other words, the average of the x's and the y's. So that's how we're going to find the center of our circle. So adding the x's, -5 plus 3 divided by 2, and then add the y values, 1 plus 7 divided by 2. Simplify that arithmetic, and we find the center of this circle is at the point -1, 4. Now, the other thing we need to know is the radius of the circle, which would be the distance, either this distance, or you could do it the other way, or you could do it the whole way across and then half it. So you've got lots of choices here. I'm going to do this distance and find my radius that way. So I need the distance formula, which is the square root of x2 minus x sub 1 squared, y sub 2 minus y sub 1 squared, and then square root that sum. So subtract, and let's see, I'm going to do it for -1, 4 and 3, 7. Between those 2 points was this distance. So subtracting the x's, 3 minus -1 squared, 7 minus 4 squared, and square root. See, that'll be 4 squared, or 16. That will be 3 squared, or 9. 16 and 9 is 25. And then this time it comes out perfectly. It does not always have to be a perfect square, but it would be a perfect square, and this time coming out as 5. So now we've got the center and the radius amount. So now we can put that information finally into our center radius form of a circle, which we saw in the last problem. Looks like this. So it says x minus the first part of the radius, x minus -1 makes it +1, y minus 4 squared equals the radius squared. The radius we just found out to be 5, so 5 squared, or 25. And that's your final answer on that problem. All right, number 28. Number 28, the question is, give the domain and the range of this relation. So it would be good if you noted or memorized all your basic shapes. This is one of the shapes we've studied, the square root function. We know the square root function is a little arc-looking figure. And then this involves our shifting rules. The shifting rules say if you have a number added or subtracted onto your x value, that will be a horizontal shift. If it's added or subtracted grouped with the x, somehow involved with the action of the x, which can be a square root, parentheses, absolute values, a denominator, anything that groups it with the x in some way, then it's a left-right shift, and it's opposite